Well, so in the last video,
Welcome to Chopra School of Physics.
welcome to Chopra School of Physics. Now in the last video we have discussed about the basic definitions like a charge, positive charge, negative charge. So now you are aware of these definitions, that an agent transmitting electrical lines of forces is called a charge. Positive charges emit lines of forces and negative charges gain lines of forces. Source charge represented by Q naught. By Q, source charge is represented by Q and test charge represented by Q naught. The field of Q naught very small, negligible, and source charge has significant field. So source charge will apply force and test charge will exhibit, or test charge will experience the force. Now we will further proceed. We will say that stationary charges charge has electric field. Moving charge has both E and B. Well, you remember, E stands for electric field and B stands for magnetic field. Regarding electric field, unit of electric field is Newton per Coulomb, and unit of magnetic field Tesla or Weber per meter square. 1 Tesla equals to 1 Weber per meter square MKS. In series, 1 Tesla equal to 1 Weber per meter square equal to 10 to the power 4 Gauss. The units are written on the basis of their discoverers, like Nikola Tesla, other was Weber, and the third was Gauss, William Gauss. So 1 Tesla is this much, it is 10 to the power 4 Gauss, and 1 Gauss is 10 to the power minus 4 Tesla. Now with the examination point of view, remembering the unit is not sufficient. We have to remember their formula also, as well as dimensional equation also. So here we will discuss how much forces are exerted by electric field. So first of all, I will write here, that is Q source charge, giving rise to electric field. Electric field will exert force, and force is E Q naught. So what I have written, Q source charge, giving rise to electric field. Electric field exerting force. Force is EQ naught. So Q naught is test charge. Electric field generated by Q, E exerting force and force experienced by test charge. So you will remember like this, that this charge, source charge, will give rise to E. E will exert force and force will be experienced by test charge. So we will say now that electric field is F over Q naught. Force will be in newtons and charge will be in coulombs, amperes. In CDS, unit will be dynes over electrostatic unit of charge. 1 Newton, 10 to the power 5 dynes. 1 dyne, 10 to the power minus 5 newtons. 1 Coulomb, 3 into 10 to the power 9 ESU of charge, and you can estimate 1 ESU from this equation, and that will be the nearest approximation. Now this is Q source charge and this is stationary. Source charge. So Q is supposed to be a source charge, but it is stationary, so it is giving rise to only electric field, and this electric field is exerting force experienced by test charge. So this is all about the stationary charge. Now there will be a moving charge. Suppose that Q is a moving charge. Q, that is a charge, and this is moving. It will give rise to two fields, electric field as well as magnetic field. Now magnetic field will exert force. Like electric field has exerted force, similarly magnetic field will exert force. So force due to magnetic field, that is F is equal to B Q naught V sine L. So I have written the second formula, like first formula was EQ naught, and now it is F is equal to B Q naught V sine L. Now here B is magnetic field generated by moving Q. B will exert force. Force will act on the test charge. And V is the velocity. V. Velocity of moving source charge. Alpha. Now this is the angle. This angle is determined by Lorentz convention. Alpha is determined by Lorentz convention. According to Lorentz convention, alpha found by using Lorentz convention. So here I will draw 3 dimensions, OX, OY, OZ. OX is indicating electric field, OY is indicating magnetic field, and OZ, the motion of source charge with velocity v. So it is velocity. So angle between B and V is alpha. So now what is alpha? Angle between B and V. B indicated on y-axis, V indicated on z-axis. Regarding this convention, you can remember that choice of field and the motion of charge is arbitrary. Like in the figure we have indicated electric and magnetic field on x and y-axis and motion of charge indicated on z-axis. It is not necessary that we do like this. Out of three axes, one of the axes will be for electric field, it can be this one also. Then magnetic field will become this one and this will be the motion of charge. Or if this is electric field, this is magnetic field, then this will be the motion of charge. So choice of axis is arbitrary. When we use the term arbitrary, means there is no restriction that which particular axis will be for which particular physical quantity. Out of three axes, one will be for electric field, other will be for magnetic field, and third will be the motion of charge. The third axis, whenever we draw, it is basically you can say this particular third line, it is basically coming out of the plane like this. So this is the projection of this particular line. So angle is 90 degrees. So when no angle specified, angle will be taken as 90 degrees, and then we can write the force according to this equation. This equation can be written as F is equal to B Q naught V, because alpha 90 degrees, because sine 90 is 1. So it means you are finding that some trigonometrical parts also we use in our equations. So F is B Q naught V, sine 90 is taken as 1. So this is the force due to magnetic field, and magnetic field can be written as F over Q naught into V, alpha 90 degrees. B is supposed to be 1 Tesla, force is supposed to be 1 Newton, test charge is supposed to be 1 Coulomb, and speed of the moving charge, source charge, that is 1 meter per second. So we have reached to the definition of 1 Tesla. 1 Tesla is magnetic field exerting force of 1 Newton on a test charge of 1 Coulomb when the speed of the source charge is 1 meter per second at 90 degrees to magnetic field. So I hope this definition is clear, and 1 Tesla can further be written as 1 Weber per meter square. 1 Tesla, 1 Weber per meter square. And 1 Tesla 10 to the power 4 Gauss, and 1 Gauss 10 to the power minus 4 Tesla, or Weber per meter square. So I think these concepts are clear to you. That is, we have gone through with the moving charge, stationary charge, their formulas, the Lorentz convention, and these formulas. When we speak Lorentz formula means Lorentz formula means force due to electric field and force due to magnetic field. And these forces I have already explained you. Their units are clear to you. And the unit for force due to electric field, that is Newton per Coulomb, or it will be dyne per SU of charge. Thank you.